Hello, algebra students. In this lesson, we're going to be learning how to factor polynomial expressions. Now, in the past, we've learned how to factor quadratic expressions, such as the ones you see here in the table. This general trinomial here, if factored using the British method, for instance, would give us an expression something like this. So 2x plus 5 times x minus 4. Maybe we had a perfect square trinomial, where the first term was a square, the last term was a square, and the second term was a combination of their roots. Maybe it could be factored using something like that, x plus 4 squared. Maybe it was the difference of two squares, where the first term was a square, and the second number was a square, and we were taking the difference of those. Well, that's going to turn into 3x plus 1 and 3x minus 1, as you see here. Or a common monomial factor. Another way that we talked about that was we talked about the GCF of a couple of terms. So sometimes when there was just two terms, maybe it was a greatest common factor that came out of both. And in fact, the greatest common factor of these two terms would be 4, because 4 goes into both 8 and 20, and x, because x is a factor of x squared and x to the first. Factor it out, and you end up with 4x times 2x plus 5. Now today we're going to use some of those same techniques to completely factor polynomials. So we've got cubic polynomials, quartic polynomials, quintic, whatever. We can still factor using some of those same techniques. One thing to note, if a factorable polynomial with integer coefficients is factored completely, if it is written as a product of unfactorable polynomials with integer coefficients. You can think of them as being prime. This example here, 2x times x plus 1 times x minus 4, this is factored completely. None of these can be factored in any further. Same goes for this expression here, 5x squared and x squared minus 3 can't be factored any further. But this expression can be factored further because of the x squared minus 4. I could factor that further into x plus 2 times x minus 2 using the difference of squares factoring pattern, something that will show up fairly often. So let's continue by going to our next page. So the first method of factoring polynomials is one that I think will be familiar to us because it's called grouping. Anytime I have a polynomial of 4 terms and I'm asked to factor it, grouping is the idea that I want to start with. So here we go. It's just like the end of the British method, for those of you who remember that from quadratic expressions. What I'm going to do is I'm going to group the first 2 terms in my polynomial and the second 2 terms in my polynomial by putting parentheses around them. I will then look for a greatest common factor of each of those 2 terms. The greatest common factor of these 2 terms being 25x squared. As far as the variable is concerned, I go with the biggest number that I'm able to take out. I have 3 x's here, I have 2 here. Well, the most I can take out would be 2, so I'm going to go ahead and take out 2. Now, when I factor out that 25x squared, that leaves me with, well, 25 divided by 25 is 1, x cubed divided by x squared is x. And then 100 divided by 25 is going to be 4, negative in fact. X squared divided by x squared is 1, so x minus 4 will be left in our parentheses. Now I want to take out a greatest common factor from these 2 terms that will leave us with the same expression inside parentheses that we see here. Well, if I want to have positive x minus 4, I think I could accomplish that if I factor out a negative 1. Factoring out a negative 1 leaves me with a positive x and a negative 4 inside of the parentheses, which is great because now I see the same binomial factor in my parentheses. So the next step is to write those 2 binomial factors, the one being x minus 4, because that would be the greatest common factor of this big term and this big term. And when I factor out x minus 4, it will leave me with 25x squared minus 1. Now, I might be done with this except for the fact that I was told to factor it completely, and I notice that 25x squared is a square. The 25 and the x squared are both perfect squares. And 1 is also a perfect square, and I'm taking the difference of them, which means that I need to apply the difference of squares factoring pattern. That's going to turn this expression into the square root of 25x squared, which is 5x, and that will be at the beginning of both of these binomial factors. And then factors of 1 are 1 and 1, and because it's negative, we get 5x plus 1 and 5x minus 1. And there's my 2 factors that I get using the difference of squares factoring pattern. Now, my final answer, I can't forget about the x minus 4 that I already had as a factor. So my final answer looks like this: x minus 4 times 5x plus 1 times 5x minus 1. Here we have a completely factored polynomial because these are all unfactorable. Next example. 10x cubed plus 20x squared plus x plus 2. Again, same premise here. 4 terms. I'm going to try grouping. Parentheses around the first pair, parentheses around the second pair. a greatest common factor of these two terms would be 10x squared. And when I factor out 10x squared, that will leave me with x plus 2. Now I already see x plus 2, so I'm going to factor out a 1. I have to factor out something. If it already is the way that I want it to be, then that's something that I factor out is a 1. I have x plus 2 inside of both pairs of parentheses, which is nice, so I'll factor that out. X plus 2. The other factor that's left over would be 10x squared plus 1. And again, I'll check to see, is there a difference of squares pattern? That's something I got to be really careful of. Beware the difference of squares is often the advice that I give to kids when we do this lesson. Well, I see a square, but 10 is not a perfect square, and I'm not taking a difference, so this can't be factored any further. This is done. And that is factoring using grouping.